Hey everyone, good afternoon. So today we're going to keep talking about sinusoidal function transformations. Yesterday's video was all about given an equation, we should be able to label the following attributes: amplitude, period, phase shift, and vertical shift, and also be able to draw the graph of that equation. Today we're going to go in reverse order. So if I were to give you a picture of the graph, can you still find all of these attributes and write an equation that matches? Okay, so just as a reminder, these are the function that we are going to follow. The letters that are in that function, A, B, C, and D, all stand for something. B and C both have to deal with horizontal transformations. So those are the letters that are going to affect period and phase shift. A and D affect vertical transformations. So those will affect your amplitude and your vertical shift. I went ahead and I wrote down all of the different transformations. That way we wouldn't have to waste time writing it down. But amplitude is always going to be that number in front. And just as a definition, amplitude is the distance from the midline to an extrema. So whether that's the max or the min, remember extrema means both. So I'm going to write that here just in case we forgot. Extrema means max and min. Okay, period is the horizontal distance for one cycle. So just how much space does one cycle make? Phase shift is the start of the cycle. Again, I should have said that the horizontal start. So when you're looking at the x-axis, where does the cycle begin? And then vertical shift is whether it moves up or down. This is going to affect the midline. So when you're looking at a graph, the midline is always going to be halfway between the max and the min. Okay, so let's look at examples. The first two on the front of the page say identify the characteristics and write an equation in terms of sine. So we are specifically going to use our sine function. Okay, so I wrote these attributes in a specific order in the way that I think is the easiest to see. If you identify them in a different order, that's fine, but you should be able to identify all of them. Okay, so let's start with vertical shift. So by the definition, up here, vertical shift, the midline is always going to be halfway between the max and the min. So when I'm looking at this graph, it has a maximum at 4, right? So I'm going to write that here, max of 4. And then it has a min of -2. I want halfway between those two values. So I'm going to add them up. -2 plus 4, and then divide by 2. And that gives me 1. So our vertical shift is 1. Our midline is going to be at 1. It's positive, so that means that it's moving up. So as far as our equation goes, so we are using sine, that tells me that our vertical shift is moving up. So right here next to that, I'm just going to write D equals 1. We're going to need that later. Okay, and just to point that out on the graph, if you look at +1 on the y-axis, that is the midline of our wave. Okay, the next thing is amplitude. Okay, back to my definition. Amplitude is the distance from the midline to the extrema. So that's why I say it's easier to find the midline first. And now we can count how far away is the midline from one of the extremas. So if I did this part right here, 1, 2, 3. That's our amplitude. You could even go down to the minimum and it should be the same thing. 1, 2, 3. So our amplitude is 3, which means that when we write our equation, A has to be 3. Okay, now let's look for our phase shift. So for the front of the page, it does say that we're going to write our equations in terms of sine. So if you remember what sine looks like, it starts in the middle, goes up to a max, goes down to a min, and it comes back to the middle. Like when you think of sine, you should think of that shape. Let me do this a little darker so we can see this shape here. So when I'm looking at my graph, I'm going to look for that shape. Now, obviously, it shows up a bunch. So what I'm going to do is I'm going to use this one right here. Okay, so it didn't start at 0. So our horizontally, we like to start at 0, and it didn't do that. It started instead right here. So we're going to call that our phase shift. So good thing is that that is labeled on our graph. That is pi over 2. So that sine little cycle, it started pi over 2 to the right. Okay, so what does that mean for us? So that is going to be our C value. But you have to be careful. So that's going to be inside parentheses, right? And we use theta. We don't use the x. If I'm moving to the right, am I going to have plus pi over 2? Or am I going to have minus pi over 2? Okay, so for this, since I'm moving to the right, it's going to be minus. Okay, now the last thing that we need to find is period. So I already have highlighted one cycle of sine. What I want to know is what is the horizontal distance for that one cycle? How long did it take to get from our phase shift, so from right here, for it to end? Okay, so to figure this out, we're just going to subtract. So I have 3 pi over 2. And then we're going to subtract where it started, pi over 2. Good thing about this is that it already has a common denominator. They're both over 2. So you could just subtract. Remember that this has an invisible 1. So 3 minus 1 is 2 pi over 2, which would just reduce down to pi. Okay. But that is not what we need for our equation. So sure, yeah, the period is pi, right? But what I need for my equation is I need a b value. So the way we find period is by getting 2 pi divided by b. So I'm going to set that little equation here. I'm going to set it equal to what my period is. I'm going to set it equal to pi. I need a little room to work this out, so I'm going to do it down here. Let's do, so 2 pi divided by b always equals period, and we already know that the period here equals pi. So how do we solve for b? So that pi, remember that it's over 1. Now we could do some cross multiplying, and that would give me 2 pi equals b pi, right? 2 pi times 1 is 2 pi. B times pi is b pi. And if they both have pi, you could basically just cancel it out. And then I'll be left with 2 equals b. So that's what's going to help me with my equation. When I'm writing it later, b equals 2. Okay, so I have a D value, an A value, a C value, and a B value. So I have everything I need to plug into here. Okay, so for our sine equation, f of theta equals our A value, so 3, sine, then our B value, which we said is 2, parentheses, not x, parentheses theta minus pi over 2, since we were moving to the right. And then last was D was 1. So plus 1. Now that is already the correct equation. We're done. But sometimes your answer choices are not going to look like that because what they do is they simplify. Meaning this 2 that's on the outside of parentheses, they actually multiply this in. So another way that you might see this is f of theta equals 3 sine of 2 theta minus pi, and then plus 1. So all I did was 2 times theta is 2 theta. 2 times pi over 2 is just regular pi. So both the same equation. It's just that if you are going for transformations, you probably want to leave it like this. If you're going for simplified form, then you're going to want to multiply that out. So actually, just next to it, I'm going to write, this is simplified version. But same thing. All right, let's do another one of those. So again, we are treating it as if it is a sine function. So it has to make this little shape here. So when I look at that, I'm going to look for one of those shapes. I'm going to go for this right here. And you could pick anyone. Like, honestly, you could have picked way over here. It's just that you would have a horizontal shift that's way far away. Always try to pick something that's close to the center. Okay, so looking at just that little area, I know that this function has a max of -2, and it has a min of -4. So in order to find that vertical shift, to find the middle, we're going to find exactly midway between those two values. So -2 plus -4 divided by 2. So this is -6 divided by 2, which would give me -3. So already I know that my D value is -3. And looking at the graph, that is probably something you can kind of eyeball. Just like that. Okay, amplitude is the distance from one of the extremas to the midline. So from the max to the midline, that looks like 1 square. From a minimum to the midline, that's also 1 square. So this is an easy one. Amplitude is 1. So I know that A is 1. Phase shift. So the way I highlighted mine, my function starts here. So if 2 squares is pi over 2, how much is just 1 square? Or it might be easier to think of it this way. 1, 2, 3, 4 squares to get to pi. So that means that 1 square would be a quarter, would be just 1/4. So this function shifted pi over 4. This time it moved to the left. So what that means for us, for C, is that in parentheses, we would have theta, pi over 4. But since we're moving to the left, plus sign in the middle. Okay, then period. So my cycle here ends about right there. So period is that horizontal distance. Okay, to find that, we're just going to subtract. I know that this is negative pi over 4. Actually, I'm going to go ahead and write that in. So that means on the other side, this has to be positive pi over 4. So we're going to subtract. What is pi over 4 minus negative pi over 4? Well, that double negative turns to a plus. So this is basically 1 plus 1 gives me 2 over 4, which I'm going to simplify to just pi over 2. So the period is pi over 2. But like I mentioned before, that's not going to help us when it comes to the equation. For the equation, we need to know b value. So period is always 2 pi over b. I need to figure out what the b value would be here. So I'm going to do down here in this corner. 2 pi over b is equal to pi over 2. Then we're going to cross multiply. B pi is equal to 4 pi. And then since they both have pi on, we can cancel that out. And we're left with just b equals 4. So for our equation, we're going to use b equals 4. Okay, now let's put all of that together. Okay, so f of theta equals 1 times sine of 4 parentheses theta plus pi over 4 and then minus 3. So that is correct, but there's a few things, like this 1 is unnecessary. We don't need to write that. Other thing is, if I were to simplify, that 4 is going to get distributed. So our final answer, f of theta equals sine of 4 theta plus pi. So I'm just multiplying by 4 theta, and then 4 times that, then minus 3. Okay, on the back side, there's 2 more. It's the same exact thing over and over. It's just those on the back. I now want to deal with them as if they are cosine. So when you think of a cycle of cosine, it starts at a maximum, goes down to the midline, to the minimum, back to the midline, and then back to the max. So when you are looking for a cycle, you're looking for that cup shape. Okay, vertical shift has a max at 4, has a min at 2. So I'm going to add those two together. 2 plus 4, then divide by 2. That gives me 3. So D equals 3, which you can see if you draw it in. That is our midline. Amplitude, the distance from that midline to either the max or the min. But from the max, it's only 1. From the min, it's only 1. So either way, our amplitude is 1, which means that A is going to be 1. Okay, phase shift. So look for a cycle of cosine. It needs to look like a cup. So I'm going to use this right here. That's my cycle of cosine. So it started at negative pi. That's my phase shift. I'm going to put PS. So it moved pi to the left. So what that means when I'm putting my c into the equation is I'm going to have theta plus pi. Okay, period. How long does it take to complete this cycle? So it ends about here. We're going to subtract. So it ends at pi minus, it started at negative pi. Double negative means you add, so 2 pi. So this has a period of 2 pi. So hopefully for this one, it's easy to see. If period is 2 pi over b, and I want it to stay 2 pi, what does b have to become? B has to be 1, because I need it to stay the same. Also, the parent function has a period of 2 pi, so that means that there is no b value. So b is 1. Now we're going to put this all together. This is cosine this time around. So f of theta equals 1 cosine of 1 theta plus pi and then plus 3. Now these ones are unnecessary. They're redundant. So we don't really need them. I'm going to take them off now. F of theta just equals cosine of theta plus pi and then plus 3. One more. I'm going to go a little bit faster through this one. So vertical shift. Honestly, I'm just kind of eyeballing it. I could tell it didn't move up or down. Its vertical shift is none. So that means that D would be 0. Amplitude. Let's see how far away that midline is from our maximum and our minimum. So if I'm counting right, that's 1, 2.5. And at the bottom, 1, 2.5. So amplitude is 2.5. So we don't like decimals. We rather have it as a fraction. So when we write this down, 2.5 is 5 over 2 as a fraction. Phase shift. Again, we're thinking of cosine. So it has to look like a cup. If I try to do this way, it doesn't finish. So that's not really a good one to look at. So I'm going to start here. That way I can see the entire cup. So it's starting at negative 3 pi over 2. It moved 3 pi over 2 to the left. So that means when it comes to our equation, we're going to have theta plus 3 pi over 2. Period. So how long does it take for that to finish here? So we're going to do some subtracting. Pi over 2, because that's where it ended, minus negative 3 pi over 2, that's where it started, is 4 pi over 2. Right? That's, and then to simplify that, that's 2 pi. Okay, so same as before, the parent function has a period of 2 pi. So if it stayed the same, that means that our b value is 1. So we're going to put this all together. Our cosine function is 5 over 2 cosine of 1 parentheses theta plus 3 pi over 2 and then plus 0. But multiplying by 1 doesn't do anything, plus 0 doesn't do anything. So I'm going to take those off. F of theta is 5/2 cosine of theta plus 3 pi over 2. Okay, so after you've watched this video, you should hopefully feel prepared to do the assignment. I made it short because I'm not there to help you. There is, I believe it's 2 questions where I'm asking you to graph, and then there's 2 questions where I'm asking you to write the equation. And be careful, in each of those equations, I tell you which one to use either sine or cosine, because it does make a difference. Okay, and let me know if you have any questions.